How we doing? Let's look at that one, not whatever doodle bob you're drawing.
I'm trying to draw him.
Well, we don't need to draw him. We want to look at that and do figure number 20.
I already know that.
What's your answer? Because I know an answer. Uh-huh.
I know it.
What you got?
Right here.
I'm gonna make a guesstimate.
What's your guesstimate then?
That's it.
I'm gonna say.
So what is your guess for number 20?
I'm gonna say 100. 110.
Okay.
But it's correct, right? Close.
What she said, okay.
Get your hand up, Donna. Okay, let me see.
Yeah, I'm actually say 90 cents. In between 90 and 110. That's how I feel. Can you count that, man?
You know what they do in the East? They make me come up with it.
I feel like I'm 100% about gorgeous. Okay, it's not going to be check your formula. Good. The bottom one's not. Check your math there.
Top one is good, your bottom one's better.
All right, let's talk this through. I've seen a lot of really good pieces on here. And a lot of us have some very good parts. So what do we notice in this pattern? What did you guys see? Yeah, you hush.
I walk in and
I know you did. I know you did. All right, what is the same in all three pictures? What is different in all three pictures? Yeah, it's only the middle that's changing. These 1, 2, 3, 4 are the same no matter what. Those 4 pieces are just kind of hanging out. So whatever is going to happen at the end. Okay. Oh, yeah, let's hurry up, put it in the bucket. Yeah, fine. Okay, so whatever's happening at the end, we know that those corners are adding 4. Right? Do we see that part? Because then what we want to do is we want to look at this middle bit and see if we can figure out what's happening here versus here versus here. Compare the purple box, pink box, and green box. What do we notice about them?
49.
It does go from a total of 1 square to 4 squares to 9 squares. Huh?
Whatever, it's, what's it?
Yeah.
It's like 2 to the power of 2.
This is 1 side by 1 side. This one's 2 by 2. This one's 3 by 3.
The next one's gonna be 4 by 4.
So the next one would be 4 by 4. Next would be 5 by 5. Whatever this side is the same as our number. Whatever this side is the same as our number. So our kind of equation here would be the side of our shape, pattern number n, times itself, n squared. So for pattern number 20, what's our n? 20. So to find the number of squares in pattern 20, square it. 20 squared is 400 plus 4. 404. Okay, so it's all about trying to find the pieces in there. When we have things that are squares that grow like that, finding an area inside is probably your best bet. I'm not saying this is the only expression for this. There are lots of different expressions you can write. You can do it as a subtraction. You can do it in all kinds of different ways. But I feel like this is probably the easiest one to see. Okay, questions on this one? Because like I said, I'm going to toss these patterns up at us every now and then just because this was a place that a lot of us struggled on that first chapter test. So I want to practice this in a lot of different ways and a lot of different times because we'll see these again. Huh? I didn't say everyone. I said a lot. Okay, we are going to be in our workbooks today. We're going to be on page 35. I know. Which is the page after the one we were on yesterday. And I believe we're going to look at 35 and 36 today. Ask for a pencil?
Huh?
I think someone asked for a pencil.
Yeah, he did.
I have a bunch. Pens, pencils, whatever we need.
Get over there, Mo's off. Mo's off. He's a big man.
Yeah.
All right. So read through this. We've got some money spent on gas. And we're not necessarily looking to solve. We're going to be putting these into context. So we're not necessarily looking for an answer. We're saying what the heck these pieces are.
Bless you.
So, our story is that you have $40 to spend on N gallons of gas that cost $3.25 per gallon. First thing we're asked to do is to decide whether it's an expression or an equation. So our first thing is to determine whether each of the following is an expression or an equation. What is the difference? My turn to talk.
The expression is something you can't solve.
Correct.
It is.
How can we tell by looking?
If there's something that equals.
Equal sign. An equation has an equal sign in it. You can kind of see it in here. Equal. So which of these, A, B, C, and D, are equations?
Like, could you repeat that?
Which of these, A, B, C, or D, are equations?
B and D.
B and D are equations. So this is an equation because it has that equal sign. And D is an equation because it has an equal sign. So process of elimination, which ones are expressions?
A and C.
A and C. Expressions do not have equal signs. So this is an expression and this is an expression. What's up? Oh, I'm gonna come back in here and hang with my friends again for a little bit.
What's up with you, bro? You just keep laughing.
Oh my gosh.
Just B, it's just them two this time.
I was gonna say, I'm just gonna just come back here and hang with my friends for a bit. We gonna chill. We gonna be good buddies.
Yeah, y'all.
There we go. All right. So then what we're asked to do is give an interpretation. They say using the structure, but give an interpretation of what it means. So looking at our story up here, what does this mean? 3.25 N.
It's the
Which one? The first one?
The first one, A.
you can add, you can change it. Like that's the thing that's like being changed.
Yeah. It's the thing being changed. What else? So I've heard, oop, let me change colors. So, yeah, so it's the thing being changed because there's some multiplication going on. I was going to put a little line here to keep these things apart. Thing being changed is not super specific. What's up?
Because I can't remember the
That's
name.
for esports. As you know, I'm a coach of esports. There we go. What's up?
Who's the head Fortnite? I mean, not Fortnite, Warzone.
We're doing Zone Wars.
That's a
Oh, different game. That's Call of Duty, right? Call of Duty? Yeah, no, they're not going to do that at school. I would say everything we do is PC gaming, not console, except for Smash. Okay, back on topic. So thing being changed is not wrong, but it doesn't really help us in terms of our gas and money problem.
That's a variable. That's
It is a variable.
That's what I was thinking.
What is the N standing for?
N,
Yeah.
I think gallon.
N is standing for our gallons of gas. It says so right here. What is the 3.25?
That's the cost per gallon.
Cost per gallon. So if I have the cost per gallon and the gallons, what would this thing make?
An expression.
Not wrong, but not helpful. So if we have the cost per gallon and gallons, what are we going to wind up with? Just the cost, right? Because gallons and gallons are going to cancel out. So this is going to wind up being the cost of what?
The gas?
Yeah, cost of the gas. To be fair, sometimes I just wait for more than one person to say it.
Or just say one.
Or maybe not have it be the one random word we say with an accent. Because we had gas. Which is fine. Feel free to go drama.
Wait, what?
Like, we just randomly were throwing out accents. It's okay. Go dramatic. I'm good with that. I mean, y'all been around me long enough already to tell.
Are you talking about Cobra Kai?
I ain't afraid of drama.
He only got one accent. So what was
Well, we went to Gus.
it? He only got one.
It's okay. I am 100% not the judgment police.
I am.
I'm not. And this room is like Planet Fitness. We are the judgment-free zone.
Micro.
Okay?
Going off here since I'm not seeing it.
So this piece just stands for the cost of gas. So then what we're going to do is see what's different between A and B and what's that going to mean when we're looking at the context of stuff. So look at this one compared with this one.
26 is how much you spend.
Yeah. So we still have that same cost of the gas piece here. This is what we just did in A. It's our cost of gas. What's that? Just let people be right here.
Get caught, especially the day before a game.
Chill. All right, cost of gas is that piece. So what is this whole thing asking? I want to know what what this equation, what is it asking us?
How many gallons will cost $26?
Yeah.
A gallon costs us $3.
Yeah.
That is so
When
You're
will
a genius.
the cost of gas, so whenever we have an equation, this really is asking us a when. So when will cost of gas, which is that purple piece,
Oh, when it reaches 26.
equal 26? And I know I have a gazillion colors over here. I'm just trying to make it vaguely capable of following it along.
26 gallons or dollars?
Excellent question. What would it be? Gallons or dollars?
Dollars, are you slow?
I look up next time.
Next time, pay attention.
So the 26 is $1. Sup? I don't know, but we are giggly. We are a giggly bunch back here.
Those two over there, the thugs.
It is not just those two, just saying. So,
Don't laugh.
we don't need to push them under the bus to save yourself.
Nah, I was the one driving the bus.
So stop tucking and rolling. All right. So looking at C, it's a little bit different.
Yeah.
The 40 is how much you have to spend.
Mm-hmm.
And per gallon is $3.25.
Yes.
So that's
So-
an expression.
It's an expression. So when you start, I mean, it doesn't have to be a question. With $40. And then I know we said that 6.25N, that was our cost of gas.
Per gallon.
That's our cost of the gas we buy. What is happening between them? We're subtracting. So if we're talking about money, what might that be? What did we do with the money?
We gave them money.
We gave them money. We spent it.
Right. Right.
And spend the cost of the gas.
So we lose it $4.
What?
Bro,
Are you slow?
Come on.
We're not,
Hang on.
we're not paying them $40.
We have $40 in our pocket.
We have $40.
Got $40 in my pocket. I got two 20s.
$26. Oh my gosh.
To be fair, that was a different equation. That was a different equation. I'm not saying we have $26 right here. We start with $40.
Of N.
All we're doing right here is we're putting things into context. Like, we're not solving these. We're just putting them into, like, words.
Did you choose one last time?
So look at the bottom one. We'll start solving on the next one. Like,
You have 40 and you spend
mm-hmm.
$43.25 on gas.
Uh-huh.
Then each gallon
Equals to $1.
Yeah.
Yeah. So if you start with $40 and spend our cost of gas that we bought, we want to know when it equals what?
$1.
$1. When I have $1 left in my pocket. How many gallons I could buy and wind up with $1 still. So you can straight up do it like I did on C, where it says when you start with 40 and spend the cost of gas, when will it equal 1? That's valid. You can also word this as, how we would word it in a question would be, how many gallons would you buy?
How many N's?
Yep.
Get it right.
To be left with $1. So you can translate it into what I call robot mode when you start with 40 and spend the cost of gas. Straight up translation. I have $40 and lose $3.25 every gallon. When will it equal $1 hands to ourselves? This guy's slowly oozing my way back this direction again. I did not even get all the way to the front before we started having some chaos over here. Okay, so these kinds of ones where we give you a story and sometimes all we have to do is put it in context. It's all about dissecting your paragraph. So we found our $3.25 was our cost per gallon. So what's up? I don't know what we're doing. Aside from being off topic. Thank you. All right, so we know it was our $3.25 per gallon, and we were buying some number of gallons. That's how we came up with our cost. So sometimes we're just going to ask you to put things into words. We may give you expressions. We may give you equations. And we just have to put it into words. Other times, we're going to ask you to solve stuff.
No.
Yes.
No.
Oh. Yes.
Yeah, that's what I'm saying. No.
It's the next page.
No.
Wait. So this is
Page 36.
Make Microsoft all these.
wait, so these are what you said?
Hang on. It's like you're making it way harder than it needs to be.
Wait,
All I want to know,
am I allowed to put in different stuff like for the X? I can put in what I want to.
can you let me finish my sentence, please?
Yes.
Thank you. For each of the equations below, we want to know if this is a solution.
Oh.
So when it says when x equals 2 or when p equals negative 2. So what will we do with those values? On this first one, substitute them in. I want to know what happens when x is 2. So if we substitute 2 in, we've got 2 plus 2 on this side. And we want to know if that's going to equal 2 squared plus 4.
It's not.
No, it's not. Because the left-hand side would be 4 and the right-hand side would be 8.
Doesn't equal.
Yeah.
So they don't equal each other, so x equals 2 is not a solution.
Throw it out. I throw it out last week.
No.
1, 2, or 0. Or is it just for the other ones?
Wait, what?
Why you say you can never use 0, 1, 2?
Oh, that's if we're picking values. I'm giving you a value.
Yeah, but
Oh.
So we're not saying is this we're not testing values to say are these equivalent. We're saying I'm giving you two equivalencies and I want you to say is this a solution. So let's look at the next one just to try that one too.
Alrighty.
And then I'm going to have you do the other three on your own.
1 plus 2 equals 1.
So we have our negative 2 that's going in place of our p plus 2 equals, whenever we substitute in, especially when we're substituting in negative numbers, make sure you put parentheses on them. It's super duper important, especially if you wind up using a calculator for any of these, that if you substitute a negative, you put it in parentheses. So on this one, What does my left-hand side simplify down to be? 0. What does my right-hand side simplify down to be? 0. So is P equals -2 a solution? Does 0 equal 0? Is that a thing? Yeah. 0 equals 0, just like 2 equals 2, or 7 equals 7. So yes, this is a solution. I'm going to ask you guys another question on this one. Does that mean that this expression, P plus 2, is the same as this expression, P squared minus 4? Are they equivalent? This is last chapter.
Yes. No. Yes, yes.
What do we think? Is P plus 2 equivalent to P squared minus 4? This is the one where you guys get to pick anything you want.
Okay, so.
We can't go to 2.4, that's
Correct.
6. No. It doesn't.
Do those two statements, these two ones these ones, do they mean the exact same thing every time? We know it works at P equals -2.
It doesn't.
Does it work everywhere?
No.
Because if it's like plugging 4 or something like that.
Technically, any positive number.
Test out a couple of values. Test out a couple of negative values. Test negatives too. That's fine.
We just did it.
We did -2. Try -3.
Yeah, is that
Try 5. Try 20.
-5.
Next, so we could just use the 2 and 0.
So if we're checking for are they equivalent, because this is last chapter stuff, if we're seeing are they equivalent and we're testing with a number, we don't want to use 0, 1, or 2 in any flavor.
So we wouldn't use the number that's given.
So on this part, we're just testing this. This is me asking you another question, reviewing last chapter stuff. Oh, snap. Okay, so we found out that this one works, but I wanted to know, is this going to work every time? If I give you a 3 here, would this still work? If I give you a 7 here, would this still work? What do we think? Because if I give you a 3, if P equals 3, 3 plus 2 is 5. 3 squared, 9, minus 4, 5. So keep going. 4 plus 2, 4 squared, minus 4. So does that one work?
No.
No. So if it doesn't work every time, they're not equivalent. That's why it's important, even when we're testing stuff, to try sometimes more than once. Sometimes we accidentally ourselves into another solution. So they are not equivalent, but this piece is true. So like, sorry, I was like rewriting things. That's definitely meant to be not equivalent. So these ones were, this one's not a solution. This one is a solution, but those two statements are not equivalent. I just wanted us to look back at that because that equivalent, not equivalent stuff, we got a little stuck on that one too. So the rest of these 3 on here, good thing it's just 3. So 3, 4, and 5, you're testing. You're just checking, do these values work? Do they work? What? Focus on 3, 4, and 5 first. 6 is a little crazy. So I just wanted us to think about this equivalent or not on that one for a little bit. So look at 3, 4, and 5. I want you guys to look at those. And math, you can do 6 too. And math, you can do 6 too. You can do 6 on that page.
so contagious.
You are giggly. Oh. I definitely forgot to put my sign.
Don't cap it.
All right. We're gonna talk these through. So make sure you're looking at us. 3, 4, 5. Oh yay! We got that. All right, what do we think? For number 3, is 0 a solution?
No, did not.
Why? What'd you get when you substituted it in? What did we get for this piece when we substituted in 0? -1. And does -1 equal the same exact thing as 1? No. So that is not a solution. How about for number 4? What do we think? Is that a solution? It's like I've heard a lot of things. Looking at number 4. If we substitute in 0, what are we going to get on the left-hand side? +1, right? 5 minus 0 over 5 plus 0. Is that the same exact thing as -1? No. So that is not a solution here. If I flipped them, it would work. Like if I switched their spots, it would work. What about number 5? What do we think? Is x equals 0 a solution here? Why not? What do we get here? Yeah, 0 minus 8 is -8. Times 3 is -24, right? What do we get on this side? -8. Because 3 times 0 is 0. Minus 8 gives me -8. So this is also not equivalent. All right. So number 6, I encourage you to look at, but honestly, they did it weird and it's annoying and doesn't really work. So we're not going to worry about it. So, end of day. So if you have not yet done homework 2-1, now's a great time to start on it. I've only given you 1 homework so far this chapter.
No.
It is, yeah, sure has, because it's called 2.1, chapter 2, homework 1.
I tried to start last night, but I was already so tired.
Wonderfully, you have some time right now. You got like 6-7 minutes. Yes, dear. Yes, I'm here to pass.